Okay, so for this question here, we're going to be dealing with theta. So theta, as a review here, if G is of theta of f, then G is both big O and omega of f, so both upper and lower. So this is another way to write that formula, the formula of omega. The formula of theta. So let's take a look. So here we want to prove this, and I'll write this out formally. So for every function g that maps from n to a real number that's larger than or equal to 0. It says all numbers a. Okay, so all numbers a real number larger than or equal to 0. If, so I'll just write this here. Then a plus g is within the theta of g. Okay, so let's prove this here. Okay, so as usual, we let this be arbitrary. And this part as well. We assume this. So we want to unpack this definition. So this is from the omega definition, we know that, let's see here, we will call this N3 and C3. If n is larger than or equal to N3, then g, the function g, is smaller than or equal to C3. And then we want to show that a plus g is in the theta of g. There exists. Okay, there exists a C1, C2, NO for every natural number. If n is larger than or equal to n0, then C1 Gn here smaller than or equal to a plus Gn smaller than or equal to C2 Gn. So let's try this here. So we want to prove we have this. So let's get access to these terms. So let N3, C3 are real numbers, satisfying assumption. Oh, and here, forgot that n be natural numbers. Okay, so first we have this, then we let n be a natural number, and we assume n is larger than or equal to n3. Then we know that g of n is we know that g of n is larger than or equal to C3. Okay, and then with that, we want to show this part here. So we will leave these blank for now. And then we already have let's see, we already have, whoops. We already have this part quantified. So we just have to say 0. Okay, and then we want C1 times Gn smaller than or equal to A plus Gn smaller than or equal to C2 times Gn. Okay. So first of all, we can get this part pretty easily, because if we let C1 be equal to 1, then we have Gn smaller than or equal to Gn, which is true, and then we multiply by C1, which is just 1, which is still true. Okay, then we have C1, which is 1, and Gn here. And then we have Gn. And we know that this is true. We also know that if we were to add A on this side, this is also true because A, what was, let's see, what variable was A? Yeah, A is a real number that's larger than or equal to 0. Okay, now we want to prove this part. So we take this here, and we move it back down here, and we say Gn is larger than or equal to C3. Okay. And we can rewrite this in the other direction. And then what we want to show is this here. So we can divide both sides by C3. And this is because we know that C3 is a positive real number. Okay, now we multiply A on both sides. And then we add Gn. And if we factor out Gn on the right side, we will end up with this value here. So again, what we wanted was C2 times Gn. Well, what this value here, we can easily write up here. So A divided by C3 plus 1. Okay, and then we set this to be 1. Thus, we can finish this.